Okay, but in Verilog program, it's very difficult to write the program for overall design. Okay, mod 24 counter in structural modeling or 60 counter or 60 counter. It's very difficult. Okay, we will write very simple code, just a counter logic which counts from 0 to 23. That counter we need to connect with this mod 60 counter which counts from 0 to 59, and that will be connected to uh, again seconds counter. Okay, so by merging these three logics, we will get this type of output. Okay, counter logic output. Clear everyone till here? Did you got the clarity from combinational latches, flip-flops, registers, counters?
Yes, ma'am.
Okay, what about Rakshita, Vinita?
Yes, ma'am. I have
Okay,
understand, ma'am.
okay. Next concept, major concept in Verilog HDL is finite state missions. So what is mean by finite state mission? What is mean by finite state mission? And what are the applications of finite state mission?
Don't know, ma'am.
Others? Why do we take in terms of states in finite state missions? Why we are taking states? Already we have sequential logic circuit to design anything in terms of flip-flop and counters, right? Any answers from Suma, Madhumita?
No idea, Prashanti.
Okay.
State is a type of conditions. Normally, this sequential and combinational logic circuits has two conditions, like the either one or zero. The
Mhm.
state in FSM, it's a state is referred as a type of conditions.
Okay. So what is the use of condition? Every time we don't have the condition, right?
Yeah.
In multiplexer, suppose, or in registers, every time we don't have the condition. So then what, like, just a common example or how we can understand about the finite state mission. Okay, fine. So first of all, finite state mission means it's a complex sequential logic circuit. We call it as a complex sequential logic circuit. Whatever the digital systems you consider, like ATM mission, okay, elevator, vending machine, washing machines, or any type of digital circuits, okay, these all are complex designs, okay, where we cannot design using small registers or small counters. We can use through the registers also, but it's a lot of circuit we need to design. In terms of lot of complexity is more, because if you want to design in terms of register, first we need to get the excitation table, where we call it as a truth table. From truth table we need to get the expression, output expression. From output expression we need to draw in terms of flip-flops, like combinational logic circuit. It takes lot of time, and functionality implementation also very difficult to write the program, okay, for major designs. So that's why all these designs we are making into the number of states, okay. We are dividing into the task, number of task. Suppose there is a ATM mission, okay. So ATM mission means what? We have number of tasks in the ATM mission, That's what we call as a finite state machine. Okay, in finite state machine, every task will be divided into the states. Whatever you have learned in digital logic design, like Moore missions or Mealy mission, those are totally different from real time. Okay, so in real time, every state will be assigned with some task. Okay, suppose ATM mission is there. Okay, so in ATM mission, first of all, when we go to near ATM mission, we will get some details. First of all, it's a reset state. Reset state means what? Everyone will think like reset means it's a zero state. The system will go to the zero state. Not zero state, it's an initial state. Okay, initial state in the sense whatever the system updated with the initialization, that will be the initial state. Okay, so first always the first state will be the reset or initial state. So in ATM mission, what will be the initial state? We will get that company logo, the bank details, the bank logo, and it will give, okay, get ready to for the transaction or something. We will get some logo or some introduction about the things. Okay, then we need to insert some pin, the card. Okay, after inserting the card, first step is initialization state, inserting the card. Next step will be we will get some data. I mean, to select the language. Okay, so sometimes we will select the language, or next it will give the list like the options like a withdraw or password changing option or cash. We need to deposit option. Something there will be lot of options. Okay, so we'll get those type of options in the next task. That will be in state 2. Okay, state 0, state 1. Suppose we need to withdraw the amount. Okay, so to withdraw the amount, we need to select withdraw option here. Okay, after selecting withdraw option, it will go to the next state. Suppose we need to enter our pin, ATM card pin. Okay, so here in state 3, we need to provide some pin number here. Okay, so if pin number, after entering into the pin number, it will go to the next state. Here we need to give some amount. So whatever we want to withdraw some amount, we need to put that amount number there. So after putting that amount number, before that, here whatever the pin number is there, if the pin number is correct, then it will go to the next state, S4. If pin number is wrong, it will go to the before state or initial state. Again, it will give you some error here, error message that ATM pin number is incorrect. Error will be given. After error is given, it go to the initial state or before state. It totally depends on design of that particular system. Okay, if pin number is correct, it will go to the next state. That's what we need to put our amount. Okay, next after giving the amount, next state will be the transaction processing state. S5, transaction processing. So whatever the amount we entered, if the amount is available in our bank account, it will proceed to the transaction to here. Okay, but if the amount is not available in our bank account, okay, it will give the error. The particular amount is not available in your bank account, or else it will go to again initial state or before state. Okay, so here amount is available, it go to the transaction processing state. Okay, now it will check here whether that particular amount is available in this bank or not. In that ATM machine, is it available that particular amount or not? Okay, if the amount is available, we'll get the cash at the final state as a 6. We get the cash. If amount is not available, it will give the error that particular amount is not available, or sometimes we'll get some server down or out of some ATM machines will not work out of service. Like that, we get some error message at this stage after giving all the details, error messages. So automatically it will go to the initial reset state if it is not working properly. Okay, if it work properly in the SS6 state, we will get the cache. We can take the cache here. Automatically it will go to initial state. Why it go to initial state? In the sense, next user need to come and use the same ATM machine. For that purpose, it will go to the initial state. Okay, so this entire process will be divided into the finite state machine. Same thing we need to write in the programming. Programming is also very easy for finite state machine. Okay, we need to define the states and we need to write the programming. So this complex design will be converted into the FSM as a task. Task 1, task 2 states. So if state is correct, next state. If state is wrong, 0, 1 options will be there for every state. One either it depends on the category. If 1 means next state, 0 means before state, like that it will be divided. Okay, this is what ATM mission. Not only ATM mission, like traffic light controller is there. Traffic light controller initially red. Red is a one state, and then yellow. Yellow is a one state, and green. Green is a one state. After green button, it should go to red. So every color we have 60 minutes. I mean 60 seconds time delay. So for every 60 seconds, the red will be on or yellow will be on or green will be on. When red is on, remaining sides yellow or green, or yellow is on, remaining sides will be red and green. These also finite state mission. We can write either using Mealy mission or Moore mission. Okay, we have two types of finite state missions, Mealy and Moore. Can you tell me what is the difference between Mealy or Moore? What is the difference between Mealy mission or Moore mission, and which one is mostly preferred by industries?
More mission.
Moore mission. Why? What are the limitations with the Mealy?
Because the output depends on the state, only on state.
Okay.
And in Mealy machine, output depends on state and input.
Okay. Okay. So in detail, we will discuss about when we are going to write the program, we will discuss about the topics. What is the block diagram of Mealy and Moore mission, and what are the limitations of Mealy? Mostly, as he said, Mealy mission, the output will be dependent on the current state and previous inputs. Okay, and Moore mission, the output will be dependent on only present output. So because of the dependency of two different states in Mealy, we'll get the glitches. Before that, you need to know the glitches concept. Okay, glitches in the sense, these two are asynchronous. Asynchronous in the sense, sometime this signal may get fast and this signal may get slowly. Okay, timing difference will be there between these two signals. Because of that, we'll get output as a suppose 1. Whenever this output is getting at the input is getting at the output side, 1. Again, within fraction of seconds, this is getting after some time, so 0. So output will be 0. Like that, within fraction of seconds, we'll get like this change in the output. That's what we call as a glitch. Okay, so we have a lot of methods to avoid the glitches also. So these glitches we will find in the Mealy mission. Okay, because Mealy mission will be dependent on two different signals which are asynchronous. But in Moore mission, we don't have that dependency. Okay, all signals are synchronous. That's why in Moore mission, we don't have any glitches. Due to only that reason, Moore missions will be mostly used in the industries. Okay, so conceptual wise, we will discuss later. Like this, traffic light controller, vending machines, digital alarms. Okay, most of the programs we use FSMs. There are a lot of even protocols. We are going to learn the protocols, right? YORD protocol in I2C also we use finite state mission. APV also we use finite state mission. Router projects. Most of the projects we use finite state missions. There are different block diagrams. Most important topic. Okay. After finite state mission, final uh, topic is memories. So what is meant by a memory and what are the different type of memories are there? What is meant by a memory and what are the different types of memories are there in digital electronics?
These are the storage element for storing data.
Okay. Next up,
Cache memory, ma'am.
in digital electronics, how we design cache memory? Cache memory. Okay, before that we will discuss the basic memories. Okay, in memory we have two types. One is a sequential access memory. What?
Volatile and non-volatile.
Okay. So one is a sequential access memory, one is a random access memory. Random access memory. Okay. In random access memory, we have two types. RAM, ROM. RAM, ROM. And one is a volatile, one is non-volatile. You already know what is the difference between volatile and non-volatile, right? And coming to the sequential access memory, we have FIFO. We are going to design FIFO, RAM, ROM in Verilog. FIFO, LIFO. Okay, so why we are telling these as a random access in the sense, suppose it's a memory. Okay, in memory we have a locations, n number of locations will be there. We call it as a addresses. Okay, address 0, address 1, address 2, address 3, address 4, address 5, or location 0th location, first location, second location, third location. Like this we have n number of locations. Okay, random access memory in the sense, to any location you can write the data, from any location you can read the data. Randomly you can access any location. Okay, so directly you can send the data to second location or directly you can get the data from fourth location. While writing the program, we can send the data to the memory and retrieve the data from the memory. In sequential, same memory, but we cannot access randomly. FIFO memory. FIFO memory in the sense, first in, first out. Okay. LIFO means last in, first out. So first in, first out means what? Suppose there is a queue ticket counter. So we went first, so we get the ticket and we'll get back. So whoever went second, second person will get and they'll come back. Third person. So whoever went first will get the this particular output and will come. So first in, first out. Last in, first out means here like this. The data will be passing like this, but output will be getting from like this. Last in, first out. Okay. So here mostly counters, not only count here, everywhere we use counters only. Okay. 0th location, first location, second location, third, fourth, fifth, sixth. Okay. So from starting of this point, 0th location, we need to write the data into the memory, and then pointer will move to the first location by using the counter logic. So we need to write the data in first location, and then the second location, pointer will move to second location writing the data, and pointer will move to third location, fourth location, fifth location. Like that we will write the data into the memory. We have the logical expressions in Verilog. By using that we need to write. Okay. So after filling into the memory, we need to read the data from the memory, right? How we can read the data? Nothing but again we'll start from the 0th location, reading the data, pointer will move to first location, read the data, and again here like this we need to read the data from memory. Okay, so here we will have the conditions also. full condition, empty conditions, all these things not required as of now. Okay, so this is what memory concept in digital electronics and how we are going to design in Verilog HDL. Okay, did you got clarity? Overall concepts of digital electronics. So what we are going to learn and what we are going to design in RTL.
Yes.
Okay. So these are just basics. I just give an overview, but in interview point of view, we need to concentrate more into logical problem statements. Okay. So already I have shared one assignment for combinational. Those type of questions we need to concentrate. Okay. Slowly we can put some time for those interview questions also. I will share you some more assignments. Okay. So yeah, if you have any doubts, please discuss. We'll close the session. Rakshita?
Ma'am, my assignment.
Yeah, I will share. Remaining? Lahari, Suma,
All good, Prashanti.
Da?
All good.
No doubt, ma'am.
Okay, okay. But from your side, practice is very important. If I want to tell fastly, I can complete the syllabus, but that's not the thing. You didn't submitted the assignment till now. Okay. So yeah, try to complete the assignment by this weekend. I will give you some more once you completed those. Okay. Okay then. Thank you all. Bye.
Thank you.